I'm Kamitani of Tokyo University of Japan. There is a high demand for technologies of gender classification. It can classify the gender of a person based on a video sequence. To classify the gender of a person, we must obtain characteristics and use them to distinguish between females and males. The movement of a person in a video sequences have recently been considered for representing such characteristics. The movements can be divided into walking movements and standing movements. Gait can be observed from walking person. GEI is a feature for representing gait. Some existing methods are using the GEI. However, the existing methods are designed for classifying the gender of a walking person. In contrast, body sway can be observed from a standing person. To the best of our knowledge, there are no existing methods for gender classification based on body sway. Therefore, we design a method for classifying the gender of a standing person. We explain analytical research in the medical fields as a related work. It investigates whether body sway has differences between females and males. Analytical studies have used a force plate placed on the floor, and they have obtained time series signals of the center positions of the pressure of the feet. They demonstrated there are significant differences between females and males in terms of the time series signals. However, there are problems. To apply such medical data on body sway for gender classification, a contact type sensor must be placed on the floor. These studies did not consider the use of cameras for gender classification applications. Therefore, we propose a method for extracting a feature from a video sequence of body sway. And we investigate whether the body sway feature can be used for gender classification. An overview of the proposed method is shown below. First, we estimate a silhouette sequence from a video sequence acquired from an overhead camera. The silhouette sequence represents upper body regions of a person. Second, we remove the variation of the apparent size of the upper body in a silhouette sequence. After that, we measure time series signals of body sway from the silhouette sequence. Finally, we extract features of local movements for gender classification. We evaluate whether the gender of a standing person can be classified based on a video sequence of body sway. We acquired video sequences of the body sway of 60 participants, 30 males and 30 females. We set the length of each video sequence to 60 seconds. These movies are examples of video sequences of males and females acquired in our experimental setting. We asked the participants to maintain lumbar pose during the acquisition of their video sequence. We assumed a scenario where people wear the same dark blue nylon outerwear in a factory. We randomly set the height of the overhead camera to be 2 meters and 4 meters from the floor. To reduce the changes in face orientation, we asked all the participants to keep looking at the timer placed 3 meters away. We evaluated the accuracy of gender classification. We compared the accuracy of our method with 2 other methods. The first is GEI. GEI reported in previous studies on the gender classification of a working person. The second is C3D. C3D with short video sequences as a representative of spatial temporal features extraction. This table shows the gender classification accuracy for each method. The accuracy of our method is much higher than those of existing methods. From this result, we found that our proposed features include better spatial temporal characteristics for representing body sway. Thank you for your attention.